Okay, so this is the practice test for the football kickoff, and I'm calling this one baseball toss. And basically, on these problems, you have a situation where do I got room to? So you got a person, and he's throwing a baseball. Get this calculator out of the way. And this baseball is going to follow some parabolic path. See how that's an upside down parabola? So this task is just going to ask you some questions on, where's the ball going to be in terms of height at different points. Okay, so the first question, it says the path of a baseball travels during a throw from a 6 foot person. So this person's about 6 feet. Can be modeled by the equation f of x equals negative 0.167 times the quantity of x squared minus 11.98x minus 35.93, where f of x is the height of the ball above the ground, and x is the horizontal distance traveled by the ball in feet. And it wants us to sketch a graph of the quadratic function. Be sure to include vertical and horizontal scales. Now, they give you a graph, but they don't give you any scales. So we need to know about what our scale should be. So the best way I can think of to do that is just to try some numbers out first. So take this equation, and let's put it in 0.167. And then let's put 0 in for x. 0 squared minus 11.98 times 0 minus 35.93. And that equals about 6. So that's 0 and 6. And I'm just writing some kind of notes down for myself, just to see what's going on. Now let's see how far this thing goes. So if I put in, whoops. Oh man. Why is it putting two negatives? 167 times. Let's try 20 for x. 20 squared minus 11.98 times 20 minus 35.93 equals negative 20. So that's a negative number. So when we put 20 in for x, we got a negative number, which means that we probably went too far. So this thing goes, and then, so we know the x scale has to be less than 20, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we can probably definitely go by ones down here. So let's go 0, 1. So again, I'm just trying to figure out what type of scale I should use. If I might need to go by 2s or 3s or hundreds, who knows. $18, $19, $20. Okay, for the vertical scale, let's see what we need to go with. Let's put in 10 for x. Negative point, because that's probably in the middle somewhere. 167 times the quantity of x squared, so 10 squared. Oh, I used 11, but good enough. 11 squared. Where's the function? Minus 11.98 times 11 minus 35.93 equals 7.8. So it doesn't go very high vertically either. So we can go let's go by halves. So every other one we'll put 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's our scales. And now let's put these points down. So I put in 11 for x, and then I got out 7.8. That's about right there. We already put in 0 for x and got 6 out. So let's put that one down, 0, 6. Let's get some more points. So I'll pause the video and then I'll finish putting my graph. So all I'm doing is just putting some x values in for x and then getting some points, and then I'm going to plot those points and then draw a rough sketch of our curve. So I'll pause the video and then I'll come back when I'm done. Okay, so when I graph this thing, this is what I got. So this curve goes up to about here, then it swoops down. So I just tried some different points out, plotted those points, and then drew the graph to those points. You see up here is that we didn't make the vertical scale tall enough. This point was about 11.9 or so. So I didn't quite make that tall enough, but maybe you figured that out already. Okay, so that's number 1. So then now let's go on to number 2.